Question 12. Unpolarized light of initial intensity, I0 passes through a polarizing sheet. The sheet's transmission axis makes an angle theta with the direction of polarization of the light. After passing through the polarizer, the intensity of the emerging light is reduced to I0 over 4. What is the angle theta between the transmission axis of the polarizer and the light's initial polarization direction? This problem tests our understanding of polarization and Malice's law. What can we recall on these concepts? We know that polarization refers to the orientation of the oscillations of a transverse wave in a particular direction. We also know that for polarized light passing through a polarizer at angle theta, the transmitted intensity is given by Malice's law. I equals I0 multiplied by cosine squared theta. This tells us how the intensity depends on the angle between the light's polarization and the transmission axis of the polarizer. Now let us calculate step by step. Taking the Malice's law equation, I equals I0 multiplied by cosine squared theta. The transmitted intensity after the polarizer is given as I equals I0 over 4. Substituting this into Malice's law, we have I0 over 4 equals I0 multiplied by cosine squared theta. Dividing both sides by I0 simplifies the equation to 1 over 4 equals cosine squared theta. Taking the square root of both sides, we get cosine theta equals 1 over 2. Finally, solving for theta, we take the inverse cosine of 1 over 2. This gives theta equals 60 degrees. This is our final answer. What did we do? We substituted the relation that the transmitted intensity was a quarter of the incident intensity into the Malice's law equation. We then simplified the resulting equation to find the required angle theta between the polarization direction of the light and the transmission axis of the filter. A summary of the key points. Polarization is the process by which light waves are made to oscillate in a single plane. The angle theta between the polarizer's transmission axis and the light's initial polarization direction determines the transmitted intensity according to Malice's law. I equals I0 cosine squared theta